Good evening. So I am Elsa Sharu Johnson from NIT Tiruchirappalli. So I am a TA for the course CS68 Python for Data Science, and today we'll be discussing the previous assignment week 4 course of week 4 of the CS68 course. So I'll expand the Colab assignment. If the screen is visible, put a yes, and if my voice is audible, yes, okay. So I'll start with the assignment. So we have to include certain data files also in between that we'll be doing. So the given data, I think the present assignment doesn't have this particular CSV file, but anyway, we'll look at that one by one. Creditworthiness data containing 1000 observations of income details of individuals comprising 21 attributes. So these are the 21 attributes in that particular data file. The problem statement is like, by observing the features of the data set, the problem statement can be defined as binary classification problem by classifying any individual into appropriate category of credit score such as good or bad. Okay, so this is the data. So we'll go on and upload the data. So it's already there, but I'll show you how it looks like. So this is the credit worthiness data. Okay, so these are the different feature columns. Okay, these are the different feature columns, and I have another data file also, which is known as creditworthiness full. So in that I have the different sheet names as objective, if you can see that here, objective, variables and data. Okay, so we'll use both these files one by one whenever they are required. So back to the Colab notebook. So both these have been uploaded. I hope you remember how to upload it from the earlier class. So the first question is, how many unique values are present in the SBAL feature? Okay, and also what is the most frequent value within SBAL? So in this particular thing, SBAL is categorical data, that is balance in savings bank account in rupees but as part of categories. If it's not readable, yeah, this is SBAL. Okay, so SBAL is balance in savings bank account in rupees, but the thing is that it is given in terms of categorical values. Okay, so these are the many different categorical as well as numerical values present in that. Anyway, so how many unique values are present in the SBAL feature, and also what is the most frequent value within SBAL? So like last time, you can go to your date extension is done by other people, Pooja. So maybe you can put in that Google Groups which is given, but I won't be able to pass on the information. Usually they won't extend it, Pooja. So the thing is, okay, those who are there, they can go to that file which is available in your problem solving session, and you can go to my drive. I'll paste the link also here, so that you can join and do it together with me. Just see if you can access that file. So this is the link. So week 4 files are there, and I have given week 4 IPYNB file. So go there, take that notebook so that you can work on your own. Okay, so yeah, so how many unique values are present in the SBAL feature? Also, what is the most frequent value within SBAL? So what we have to do is, first we have to import the required necessary libraries, which are NumPy and Pandas. Usually we'll do that. The rest of the libraries that we require in between will be added as and when required. Okay, so when we are doing some classification algorithm, the required libraries will be added at that time. Whenever we are doing something else that you have studied, like splitting data or pre-processing data, that also we'll include at that time. Okay, so right now these are the first libraries that we'll be importing, and then we'll be importing the data creditworthiness.xlsx. so it's an Excel file, that's why pd.tc read Excel has come. Okay, last class we have looked at read CSV and many ways of reading the file. Okay, assignments, you have to keep the timing. Okay, maybe I don't know, you might have to go to Q&A and see if it can be extended. You can put your query there, otherwise that will be the last day. Okay, so yeah, then so data read CSV. Then what you can do is, first you have to, so first when you get any data, you have to do head, tail, sample, info, describe. These are the initial steps that you can do in any file that you are getting first time. So first when you do a head, you will get the first 5 rows of your particular CSV or Excel file. So you have a header, it's automatically taken, and since there are 21 columns, some are getting hidden. Okay, some are hidden, all won't be displayed, and then these are the 5 rows. Okay, so you can see credit history, credit duration, like that. So this is like, these are the descriptions of the data. Okay, so C balance categorical, C duration numerical, C history categorical. So we have to see whether everything given in this way is true or not. Okay, everything that we are getting in the Colab file is the same. So first, okay, we have done a head. Now we'll look at it at the info tail. Anyway, I'm not doing it now. So you can see cbal is an object, C duration has come as an int file. Okay, C history as an object, so like that it's come. If I look at the Excel file, then the Excel file also is looking in the similar way. Then the variable is credit score, and it is categorical. That means chances of borrower closing his credit promptly, categorize it as good or bad. So that is the thing. So now we have all these things, and credit score also, it is an object, and everything categorical, numerical, everything. I think everything is coming in similar way, so it's all right. Now data dot describe. So this we have seen last time. We had seen last time like data dot describe include equal to all also. Last week we have seen, and that time I've shown you like how describe varies when we have nothing inside as arguments, and when we have include equal to all inside that. Okay, so if you give it just like this one, you will have all the numerical columns displayed. So these are the numerical columns which are present in our data set. C duration, C amount, that means credit duration, credit amount, interest rate, age, numerical credit, number of existing credits, numerical, and numerical n depend, number of dependents, that is numerical. All right, so these are the things. So our first question was how many unique values are present in the SBAL feature. So SBAL, we found out that it is categorical and it is balance in savings bank account. So it is categorical, right? So we have to see the categorical value. So in the describe, either you can put output of describe is only for numerical type columns. Yes. So but if you remember my last class, we had just given in this way last class. There are many ways to do something. So if you put include equal to all, then you can get every data, both object as well as numerical. So if you don't need that and you just need the object columns, like only the categorical columns, you can use include equal to O, which denotes objects. Okay, so that is what we need right now, because SBAL is object only, but we need not go to all these things. We'll see another easy option also. So this is the describe include all, this one. Okay, and include as an object. Okay, so this shows only the object values. Then we have the count of the object value. Capital O is yeah, it is accepted. It denotes like object. Okay, so if you just go there, include like missing assignments are graded, so I mean it might affect your final thing. Okay, these all things you can just put in the FAQ. So wait, people are joining. Oh, all right. So I mean it depends on the syntax. Okay, here you see this is the function description of describe. So include equal to O gets category. Someone has raised a hand. Can you first put in the chat window? The one who has raised the hand, you can unmute. Okay. Shubham, yeah, I mean in Colab, if you just hover over that place, okay, you can open it. If you want to do so, okay, you have to be, it won't stay for like a time. Okay, so it might go. So if you hover over that place, just wait a minute. Okay, so this is the, if you hover over that thing, you will get this thing. All right, in Colab it comes like that, and in other things in Spider you have to have open the help of that function. Okay, and what is that? Yeah, so O means it's categorical. Okay, then so this is include equal to object. Now if I give include equal to object dot t, which means toggle. Okay, so if I do that, now you can get in this way the same thing toggled, so that you can observe everything clearly. So here you can see CBAL 1000 counts are there, unique one, the top frequency, which unique value is occurring most of the time. Dot t means dot toggle. Okay, this one, so this one is this much is what we have seen here. Okay, it is coming in the form of matrix, you can say, and if you put dot t, then it is this way. All right, share, I already have shared, I'll pin it, the drive file, and it has the model of this notebook. Okay, so you have to type in that and take it. All the CSV files are also given there. Okay, so you have to type and do it. Usually t.t means toggle for any data frame or any series function. Okay, yeah, so usually if you put toggle, that means that only. It is a property of a data frame. See, you can see, no, the transpose data frame. So for every data frame, if you simply give like even a data frame you read to data and data dot t, it means that transpose of that function, that's not transpose of that data frame. So that's what it's done. It's usually done for data frames only, because since we are working with data frames, it's already Jupyter notebook. It's better to have them in your same file, or otherwise I will have to load the Jupyter notebook to show you. You can just mention your file path there. All right, and after that you can do this one. I'll show you, let it load. Okay, so this is, you can see, include equal to o dot toggle, and so you can see. So what was your question? SBAL, you have to find the number of unique numbers, unique categories present, and the top category is less than ₹1000, and this is 603. So what is that? Yeah, so yeah, then the same thing, if you just don't want to look at the describe everything, you can go for this n unique. Okay, so data.sbal means data is the data frame, sbal is the column name. Okay, so sbal is the column name, and if you put n unique, then you can get the number of unique values, which is 5. So this is like n unique and unique function. So okay, what it, yeah, then if you get this one, sbal dot unique, if you do, then it will show you what are the unique categories there. So these are the unique categories there in sbal function. Okay, so that is what is there. Now the same thing, if you give data frame, same thing if you give data frame and in brackets sbal dot n unique, that also will give you the same answer. Okay, many ways to do the same thing. So, and this one, what I am doing is like the data.sval, I am giving as a new NP array, and to if you, this I've just done to show you if it's a numpy array what you have to do. So if it's a numpy array, then you can just go and like, just wait a moment. Okay, so If it's a numpy array, if you want to change to a numpy array and find the number of unique elements, so sometimes you will be asked to find out the unique elements in a numpy array, right? So if you want to do that, then what you can do is so for the files also, just wait a moment, I'm just doing the so if it's a numpy array, if you are given a numpy array, then you might have to have you might have to use differently to find the unique elements. Okay, so that way you can have data.sbal, this is your data frame. Okay, and if you convert it to np.array, it becomes a series. Okay, nd array, like that. Okay, so just data.sbal is a series because data itself is a data frame. Data.sbal will become a series, and we are converting that series to a numpy array. That is why we have given np.array data sbal. Okay, so just wait a moment. I think I have to download this file also to show it there. Okay, yeah, so just I will bring that interface now here. Okay, so you can see it here, right? One who had asked for unable to understand this topic, I will once more tell it, Shubham. So who had asked? Vikram. Yeah, Vikram, this is the Jupyter interface. Okay, and so here, okay, first if you have to start, just anyway I will just restart everything. And right now this is just I've given my downloads file. Okay, so downloads, this credit worthiness is lying in the downloads file. Okay, so just if I move on to downloads, this is the path of downloads. So in the downloads it is there, right? So, or what can we do? Yeah, so if it is in the same file, it will come okay, right? If it is in the same folder, because right now this particular credit worthiness as well as that thing, same file is in downloads. Okay, now if both of them are in a different folder, okay, say for example I am changing it to desktop documents, like new folder, and I am putting in a new folder. Okay, I hope you can okay, it might be a little difficult to see, but still, yeah. So now right now in documents it's in a new folder. Okay, so I'll come back to the Jupyter notebook. Okay, and I will move on to documents, new folder. So right now these two files are there. Okay, so I will open it here, and anyway both are in same things only. So yeah, so just if it's lying in some other place, so right now this is the folder path. Okay, so what you have to do is you come here, you come to this place. So what I'll do is I will add a text. Okay, just folder path, I will just give like for the credit worthiness it is this folder path. Okay, and you can use the same code. Yeah, so one thing you have to make sure is that your folder path in your computer is in the form of backslash, okay, backward slash. But if you want to give it in here in the path of the Python, you have to use a forward slash. There are many methods you can just like call, select the file also. So in Python, if you are using, you have to give it like forward slash, or you have to give it like, so this one folder path I will to be used, I'll do. And another method is, so this is when you are giving the address, okay. So another method is like the same thing. If you give, I mean if you are using backward slash, then you have to use a double backward slash, okay. So actually this is the original folder path, okay. This is the original folder path, and the path to be used is this one, okay. So first we will take this one, right, we will take this particular thing, and then we will see, okay, if it's being read. So anyway, first we have to start with the thing, and just this is the original path and folder path, and this I'll share later. So then if you do like this, okay, if you use this folder path here, then you can read. I hope you understood. Vikram? Okay. Then moving back to the Colab. So Colab is still connected, right? Yeah. So Colab, I hope you are using all of you are using Colab, because anyway I have shared with you the drive also. It's better to open in Colab, okay. Yeah, so the same thing, let me just minimize the Jupyter. Yeah. Okay, so what is it that you don't understand, Shubham? You can unmute and ask, or you can put in the chat window. So anyway, what I'll do is like, just from the beginning I'll just explain, okay. So this one we are used to find out how many unique values are present in the SBAL feature, okay, and what is the most frequent value within SBAL. So for that, we first read the file, we found out the head of that file, meaning like first 5 rows, okay, and then we did the info. So in the info, and then the describe. So in the describe, if you simply, yeah, so if in the describe, if you simply use it, you will get only the columns which are numerical. If you give include equal to all, you can see every file, both categorical as well as numerical. And then if you use include equal to O, you will get only the categorical. So for this particular question, if you use data.describe include equal to O, you will get both the answers simultaneously. Like it had asked for the most number of unique features in SBAL and the most frequent one. So since this is little bit hard to see here, I am using the toggle function or the transpose function, okay. Transpose means like your rows will be columns, columns will be rows, right? So I mean simply describing, that is how you can do it. So if you do data.describe include equal to O dot T, which is toggle, then you will get count unique top, and frequency as the columns. So in that SBAL you can see count is 1000, unique 5, and the top means the categorical value or feature which is occurring more is rupees less than 1000, and the frequency of that is 603. So 603 times that particular category is appearing. Okay, so rest of the categories are appearing lesser than that. So the same thing, like if you want to find out the number of unique elements or unique features in that, you can use sbal.unique, or if you use sbal.nUnique for the numbers and sbal.unique for finding the unique categories in that particular column. Okay, so sbal is the column, data frame is data. So data frame, how to upload? You don't have to upload, you just want to have that particular CSV or Excel file in your system. Okay, oh, in Colab you're asking. Okay, in Colab there are different methods, many different methods. One easy method is like going to your files tab and upload to session storage, you can see here, then coming back and go to where your file is present. So right now my file is there in this particular folder, so just type that folder, and in this way you can do. Okay, you can search the file, you can do. You can do that. Yeah, so the same thing, where is it? Yeah, this one, if you do data.sbal.value counts can be done. Okay, so what it shows is like for each category how many things are there. That can be done, yes. So this one, if you do, that's why many things can be done. Okay, without doing itself, if you want to find so many things at once, if you want to see what is the number of unique, what is the top category occurring, and what is the frequency, everything together, if you want to observe, just to describe is better. Like, so otherwise we have to put a different function for everything, no? So this one function itself will show you all the details together. Okay, so anything you can use. Value counts is also right, Vivek. Then, so this is another way. So there are many ways. So if you have data.sbal, so this is like, this will become a series. Okay, and then if you convert it to a numpy array and store it to data.sbal, so now it is an n-dimensional array. So in this one, in numpy, np.unique you have to call. Okay, and you have to put sbal there. So find the unique elements of an array. Earlier when you hovered over the unique, you can see that returns the unique values of a series object, because right now if we do like this, this becomes a series and it goes like dot unique. Now if you do here in this way, this is a numpy object, that's why numpy also has unique values. Okay, in that unique function. So for a numpy unique, you have to have a numpy array. So np.unique data sbal, which is right now an nd array, and if you give unique and count, so return counts equal to true you have given, so you will get the number of unique elements as well as the frequency. So if you run this one, you will get the unique elements as well as the frequency of unique elements. Okay, so these are the different ways. So the answer for this particular question is which one? The options I will show you once more. Okay, so these were the options. So the answer will be, I hope everyone has done in their notebook. Yeah, let's see. So the answer is C. Now, so it's C. Then find the average age of the customers who have a credit history C hist wherein the dues are not paid earlier. Okay, so now the column which is in question is C hist. Okay, so C hist is categorical pattern of credit dues payment over time. So if you go that these are the options, all right, 35.54, 38.44, 33. Okay, just remember these options. Now we have to find the average age. So first we have to find out the columns which are having dues not paid earlier, right? So if you go to this thing, C hist is like all the settle now is the most frequent column. So what we can do is like first to see which all are the number of things there. So first what I'll do is like C hist, I'll do a value counts. Okay, so value counts I'll do, and data C hist value counts will show you this is the topmost frequency 618, dues not paid earlier 293 are there. So we have to find out the average age of the customers who have this credit history. So there are 293 people there. So first what I'm doing is like first data history wherever dues is equal to not paid earlier, I am finding those places. Okay, I'm finding the length of that. Okay, so as you know here it's already we have got it as 293, so you will get it as 293. And then what I'm doing is like first I will keep it to, I will take that separately. So this is like data frame of a particular statement. That means wherever those data frames are present, that particular statement is correct. Okay, so now I have put like data of this particular argument, means that wherever this particular argument is coming, right? So in that particular thing I am taking age of that particular data frame. So if you are finding it difficult to know what happens there, I'll just do it one by one. So first what I'll do is like I will do a pay age edit. Simply I'll give a name. Okay, so pay due, sorry, I meant this one. So pay due underscore edit I have put like this. Okay, now if I just do, so this is like I am just collecting a data frame which only has these values. Okay, so what can I do? I'll just see the head of that function. Okay, so if you do that and this is like C history, see dues not paid earlier, dues not paid earlier, dues not paid earlier, everything is that only. Okay, so what I am doing in this particular statement is like I am collecting all cases where dues are not paid earlier, then I am putting age in that. That means, so instead of this statement we can give the one which we have given here. Okay, so already we have placed it to a new data frame. So if we put pay due underscore age underscore edit of age means just that column. Okay, and now we are doing the mean of that column. So this is given in pay due underscore age. So right now it just contains a numerical value. So if I just print that value, print pay due underscore age, you will get this value. Okay, now in your answers there are only 2 decimal places. So what we will be doing is like we will be rounding the value to 2 decimal places. So that is what is the answer. So you'll get 38.44. Okay, so this option is option B. Okay, so anyone has any doubt in this one? If there is any doubt, please tell me. Otherwise, I'll go with the next question. In between, if you have any doubts, you can turn on your microphone also and speak. Okay, any doubts? All right, I think what we considered first, meaning like, so the question is like, find the average age, right? So what you can do is like, first you have to find where the average age, where the credit history is like dues not paid earlier, that you have to find out first. Okay, so it can be done in a simple line also, like print, okay, then if you take the round, okay, of something, okay, so we want to find out where the data was there. So first you have to put data of, okay, so data of, so first you have to find out, I'll copy this one, right? You have to find out this statement, okay, data of data dot history, data of C history equal to dues paid not paid earlier. So this is your thing, okay, and in this one, so this is your data frame, and in that you have to consider the age column, okay. So first you need to know what is your column name, that you need to be sure of. So here just first anyway, so you have to see what is the a name given for the columns. Sometimes it might be capital A, sometimes it might be small a, that you have to consider. So right now it is small a, that's why we will be giving here age. So now we have data C hist not paid earlier, okay, data of these not paid earlier of age, then dot mean, okay, then mean of that function. So then after that we are rounding that and printing that. So I have to check if everything is there, okay. So this is actually can be completed in a single step, okay. So you can have, so round I haven't given two places, right? I've just given round, that's why it came like that. So if I am giving like round comma 2, okay, then I'll be getting 38.44. So first what do we have to consider? We have to consider the data frame where this particular statement is coming. Then we have to take the age column from that particular place where it is coming, and then you have to take the mean of that, and then you have to round the answer. Sujit, you have raised your hand. What is your question? So I hope that's fine with you. Yeah, okay, then next question, a logistic regression model. So the earlier answer was B. Any questions? Okay, a logistic regression model is built in which none of the features used are standardized, okay, none of the features are standardized, we will get to that. The train to test proportion is 75:25 and the random state is set to 1. The accuracy of the model is, so I hope you are all aware with the logistic regression model which was given last class. Anyway, just I'll browse through the thing very like simply just have to find the cursor. Okay, so logistic regression. So from the lecture slides you might have found what is logistic regression and linear regression, right? So for linear regression problem the output is continuous, but for logistic regression your output or dependent variable, or also known as target, will be categorical. Okay, so in our particular function problem here we have categorical target. Which is our target? Or looking at this is our target, this is our credit score, which is the target or the dependent variable. Okay, and all the rest are independent variables, right? Or you'll also say call them as features. So CBAL till foreign are features, credit score is target, our target is categorical, and this is the chances, it is explained as chances of borrower closing his credit promptly categorized as good or bad. So there we have two classes which are given as good or bad. So moving on back to the thing, so we use logistic regression when the dependent variable or target is categorical. Okay, so for logistic regression we'll use a sigmoid function. So earlier, so I'll just explain with this one. So in linear regression you might have learned that it's just like your straight line equation problem. You will have a y and you'll have an x. Okay, between the x and y you will be having some function like y is equal to mx plus c. Okay, you will have your y, which is your continuous variable, and then you will be having mx plus c, where this y is your target variable and x is your, I hope it's visible, right? Yeah, x is your features. I'm just putting features. This means that features denote independent variables and target denotes dependent variables. So this straight line equation usually means that m is a slope and c is an intercept, like that we have learned. But here in this case, in linear regression, what we are trying to do is we will be doing a straight line. Okay, and then we'll be trying to fit the points in a straight line. Okay, so that is what we are doing in linear regression, but we can't do the same linear regression for a categorical problem, because if you look at here you have two values. So using a PDF of what, so okay, just I have to come back to your thing. So it's like credit score is good or bad, no? So I'll come back to here. So here so that, I mean, depends on us only what we'll do for that. So here what you can say is like, let me just take it as y equal to 0 as PDF of previous question paper. I have to check that for that, Sujit. So just wait a moment. I don't know if I'm having that PDF. I can send you the notebook, okay, but I don't know if I'm having the PDF. So I'll just take that y equal to 1 as good and y equal to 0 as bad, okay, just for the time being. And you can see that some set of values, the bad values are there, and y equal to 1 values are there at the top. Okay, so if I do in this way, actually what will happen is that if I try to fit a line, so here these are lying there, right, at the top. There is no line which you can do in this way. If you just put a y equal to line like this, maybe someone will tell you like if you put a line in this way, you can separate both the classes. Okay, fine, sometimes it can happen also, but sometimes you will get a new data point like this here. In that way, you can't just fit a linear regression for a classification problem. Sometimes people usually do with that also. It can happen, but it's better to use another regression problem. Okay, there you have to do certain other changes to use that, but still, so we don't use linear regression problem for categorical problems. We will use logistic regression. So logistic regression is the same. Okay, just I will erase everything. So it is the same here, but the extra thing which has come is the sigmoid function or the logistic function. Okay, so what happens is that if that is used, you will have a separation like this way. Okay, so whichever is falling in this portion will belong to y equal to 1, and whichever lies in this portion will fall to y equal to 0. So what is that logic function and all? You can browse through the videos also, but it just means that it is a log odds function, which is also given like logit function. So logit function means it will calculate the odds for an event. Okay, so usually this is what I have explained earlier. For linear regression, y is equal to mx plus c format is there. Here m denotes beta 1 and c denotes beta 0. For logistic regression, the log odds of a categorical response being true is modeled as a linear combination of features. So this is like p means this particular line is like probability of an event occurring by probability of an event not occurring. You can't say that logistic regression model is more accurate, depends on your target function. Okay, usually we'll use linear regression for continuous target variables and logistic regression for categorical. Okay, first, but when you are starting with every model, you can just fit a linear regression also. You can just try. They'll throw you an error, but you can make it like for example, if you use a linear regression model, your target variable has to be taken like an integer. So for example, when even in every regression model, you have to convert your target variable as either 0, 1, 2 or 3 something. Okay, so that particular operation is known as encoding. We'll see it just after some time. So encoding, if you do, and then we'll give it, if we are giving to a model, then it will be accepted as a category. But encoding the same thing, if you are changing that data frame as an integer, and maybe you can use it for a linear regression, because it is just seeing like 0 and 1 values are there, it will be taking as an integer value. So there are ways which we can do that, but usually if you simply throw a categorical target value to a linear regression model, it will show you an error. Okay, and it is like expected also, and usually we will not use it for categorical target variables. Okay, we will use logistic regression for categorical variables. The same way we don't use linear regression for categorical models, categorical target variables. Okay, so you can't say this is more accurate than linear regression. You can't say that. It's different. One is for regression and another is for classification. All right, so this is what is happening behind. So since ours is a category, we will be taking the probability. For regression problems, regression usually means that fitting a line, right? So for regression problems, the y is equal to mx plus c line will be there. This is the y is equal to mx plus c line. So we are equating it to the log odds function, which is this one, the log odds function, which is this one. Okay, so the log odds function is like odds ratio. If you say probability of an event occurring, p of x, by probability of an event not occurring, 1 minus p of x. The log of that is equated to your usual straight line equation. So that will give you the logit function. So if you solve for this one, so how do you solve for this one? you have to find out what is p from this equation. Okay, so you have to bring it everything to the other side. So if you bring log to the other side, it will become exponential of beta naught plus beta 1x, right? I will simply write that. Okay, so if you just, so how you do is like p of x by 1 minus p of x equal to, it will come like e raised to, if you bring the log the other side, e raised to beta naught plus beta 1x, right? And now after this, if you solve, okay, if you solve for this one, so you can see here, this is right now p of x by 1 minus p of x is equal to this one. Now p of x is equal to 1 minus p of x into e raised to, it will come, and after solving you will get p equal to 1 by 1 plus e raised to minus beta naught plus beta 1x. So this is how it looks like. So this was your earlier straight line model, and now you have a sigmoid curve there. Okay, all right. So yeah, so logistic regression outputs the probabilities of a specific class. Those probabilities can be converted into class predictions. So it takes on an S shape. So I'll share this notebook also, and I've given links there where you can go and see the basics. Okay, so this is, you can go through some links there. I can share the links also later, and it's already embedded there, so you can, and I've also included the link for a video. Okay, so coming back to our question, so we have a logistic regression model built in which none of the features used are standardized. Okay, we'll come to standardization now. So first you have to standardize. They are telling that none of the features are standardized. Then train to test proportion is 75 to 25. I hope you have seen from the lectures that what is train test split ratio, and random state is set to 1. The accuracy of the model is. So for that, okay, just many things are there right now here. We'll see one by one. So OS is sometimes if you want to search which select which thing to load from. Okay, and just Seaborn you have seen last time. Scikit-learn is the library where, I mean, it's actually now it's an old library only, but this is where most of the basic things are present. Okay, functions are present. So in the scikit-learn library, in model selection you have trained, test, split, and in logistic regression is there in the linear model. Then you have to use many metrics for solving your classification or regression problem. So you have metrics in scikit-learn. Scikit-learn means sklearn only, that is the kind of, you can say, the abbreviation. Okay, and sklearn dot pre-processing has standard scaler. So everything I've given here, so just everything that is needed for this function, so for this particular problem. So this is scikit-learn, as you can see here, right? So scikit-learn in the train, test, split. So how you have to call that is known as the API reference. So scikit-learn dot model selection, you have to import from that. Okay, so import scikit-learn dot trainers model selection, you have to import train, test, split. Okay, now the other thing is logistic regression, so that is present in scikit-learn itself and inside linear model. So you can see here in linear model you have logistic regression, many other cross validation, many other things are there. Okay, so each of these things, so many types of regression as well as classification will be there. Now these are the metrics that we saw earlier, so you can go through each and every one of that separately. So metrics I've already shown, and classification report, that also is kind of in the metrics only. Okay, just to show you, this is scikit-learn dot metrics classification report. So what all these things are, we'll go one by one. So first what we'll do is like we'll load the data. and this time I am using credit worthiness full. This is the credit worthiness full Excel sheet. Okay, why is it given as full? Because it has the objective given in a special sheet, variable description in the second sheet, and the data in the third sheet, so that they are named as objective, variables and data. Okay, so what to import, I'll tell you. Yeah, so this is an Excel file right here, right? So Excel file, you can give sheet name equal to data. Okay, so first, so if you just read it there, what I'll do is, we will see what happens if you directly give like this. Okay, so if you give in this way, we will see whether a head works. Okay, so it will come in this way. Okay, so you might understand that there is some problem with that. Sometimes you might have to look what happens there also. So what I'll do is, like, this is an Excel file and different sheets are there, so you have to specify the sheet name. So if you specify the sheet name, then you will get the data dot head correctly. Okay, so now it will take correctly now. So yeah, I mean, we have to form a model, right? We have to build a logistic regression model. So first what we have to do is, like, our target column is in the way of, so see our target column, credit score, it is written as either good or bad. So for using a logistic regression model, we have to convert it to some classes, okay, like 0 or 1. So what we are doing first is, like, we are doing credit score. We are taking that particular column, and in that column I am doing a map function. Okay, so it is like apply a function to data frame element wise. Okay, so if I am doing that, I'm just putting good should be named as 1 and bad should be named as 0. So this kind of operation also, there are many possible ways by which you can do this. Okay, you can have label encoding, you can have a program or a function written to do encoding, many things you can do. So another example, I'll show you another way of doing this one. So right now, since there are only 2 classes, you can just directly give data of credit score dot map. In the map, you can give good equal to, I mean good as 1 and bad as 0. So now if you do that and you have a data dot head, you can see that wherever the good was there is now transformed into 1. Okay, so just see some time before. So earlier it was like credit score good, good, bad, bad, good. So now it changed to 1, 1, 0, 0, 1. Okay, so we have done the mapping of the columns. Now data dot columns, if you give, you can see what all are the columns in that particular data set. So these are the list of columns. Okay, now what you have to do is, just before doing that, I will show you a data dot info. Okay, so the data dot info will show you that credit score. Okay, so these are our datas. Earlier when we had good or bad, it was an object column. Okay, if you remember, just I will go fastly to the other one. So earlier when we looked at that, when it was still good or bad, it was looking in this way. Okay, it was an object. Now we have changed or mapped it to 0 or 1. So since we have done that, now what happened is, like, they took it like an integer value. Okay, So this is what I told you. Sometimes if it comes like that, sometimes people can use it like a regression, but it's not actually a regression, it's actually a wrong thing. And if you directly give this to a logistic regression model, then it will tell you like there is an error. So right now I'll show you. So imagine that we don't do these things, okay? We don't do get dummies function. So what I'll do is like, so x equal to data drop columns, okay? So yeah, so if I just give like this, okay, okay, I didn't close it, and so x is like this, okay, and right now I am hiding this one, commenting this one, and y is like our data of credit score, okay. Now if I do for a splitting and I am running the logistic regression model, you will get the value like could not convert string, not checking account, okay, like that you will get, okay. So they'll have an error. So actually it is come in a different error, I think, yeah, but anyway I'll show you. So just wait a moment, somebody's okay, yeah. So what I'll do is like I'll remove that one and I'll put it in the normal way. But still, why we are doing this pd.getDummies, so that I will mention. So the getDummies method is used for data manipulation. It converts the categorical data into dummy or indicator variables. So this is one way which you can do. So with an example I'll show you. So you have a list like this, okay, a b c b a, like that, a series is there. If you do a dot get dummies like that, and then your output will come in this way, abc it will put, okay, and wherever a comes, so this is like a b c b a, right? So in the first row a is coming, so it will be coming as a 1. In the second row b is coming, so a is 0, b is 1, c is 0. In the third way c is 1, like that it will go, okay. So if it's not clear, we'll look at another thing. So this is a data frame, okay, pd.data frame, r like acd, t is like dac, and s is 1 2 3, and we are doing a pd.getDummies function. So what it will do is like s, it will give you 1 2 3, okay. Then the other one, first one, column a, column c, column d, wherever it is appearing it will come as 1, and wherever column d, c coming, it was appear as 1. So like that it will convert, okay. So first we will do that for this one, and we are giving drop first equal to true. Drop first equal to true means the original column will be dropped, okay. So we are giving x equal to pd dummies, and y means we just need the target variable in y, that's why y is just data of targets credit score. Now if you do x dot columns, it will look in this way, see, c duration, c amount, interest rate, age, like that, and our categorical columns. So just our example, cbal was a categorical column, right? And in that cbal, in that cbal, yes, sorry. So cbal had many different types, like 0 less than equal to rupees, like that, 200, like that, then like no checking account, like that. So if we did like this for each of the things, so for cbal 0 first column less than rupees, like this is the first column, then second column will come like this one. So wherever this condition is coming in under that column, it will come as 1. So this is what pd.dummies does. And we are giving train x, train y, like that, like that, like that we are giving. Now if we run the logistic regression model, okay, so train test split is like this is train test split. So what we'll doing is like there are x and y values. So x means our independent variables and y means our dependent variables, and xy we'll be splitting as training set and testing set. Okay, so for splitting to training and testing set, we have the train test split function. So its arguments are like you have to give the independent variable, that means features, then dependent variable, then test size. So it is given like 75% training and 25% testing. That's why test size is equal to 0.25, and we are specified to give random state as 1 also in the question, so that's why we are giving it like in this way. All right, then why we are splitting as training and testing set? Because we need some set of values to test our model, right? So if you are doing like you are using the whole data and you are training your model will fit nicely, but you don't know if a new data comes how it will be working. So for every regression or classification problem, you will have a training and testing set, and sometimes for very huge data set you will be having training, then you will validate the model using a validation set, and then you will be having a test set. So the number of operations that you should do for a training and testing set will differ. Okay, so your training set is where you will do all the training and your model will learn from the training set. Test set is something which the model hasn't seen any time during its learning period. Okay, so during the learning time of any ML model or a DL model you are using, you should use only the train set. Okay, so in the train set it will be learning, but we don't know how effective the model is, so we need a test set. So that is known as testing data set. So if we are using a 75% of the whole data as training set and 25% as testing set, it's known as a 75:25 split ratio. All right, now this is our logistic regression function. So it is there in scikit-learn.linear model. I've just mentioned what logistic regression looks like, and this is how you implement it. Okay, now the different things behind that and how you can do it, you can see from here. All right, and I hope everyone is clear, and if you want 1 or 2 examples also, it's given here. Okay, you can follow that. Now what you can do is logistic regression, you can just mention maximum number of iteration what to follow. If you don't mention anything, the default value will be taken. All right, the default value is okay, maximum iterations default value is 100, so 100 iteration is the default one. I've just given 1000 iteration to see how much it will like go up to 1000 steps. Okay, iterations. Now this first we have to call the logistic regression model to a particular name, and then we give this dot fit train x train y. You can just complete all this in a single line also, just by giving logistic regression dot fit in this way. Okay, so then this is the learning part of your model, logistic regression model. Okay, so for the learning part you are using the train x and train y. All right, now for the testing or predicting how good your model is, you need to use the test function. So you are using the test x and using the dot predict function. That means that whatever has been learned by this logis mode, which is the logistic regression model, it will use that particular model to predict for the test set, and the predictions are given as the name prediction underscore log. All right, So this is what is the result that the model is giving, and test y is the original test set's target value. So we have to compare with this test y and this prediction log to see whether these both match. If they are matching completely, you will get like 100% accuracy. If they are not at all matching, then you will be getting like a very low value, right? Like very low accuracy. So we will find out how our model works like. So for that, you have many different metrics, like we have seen in scikit-learn.metrics, right? There are many metrics there. Now we'll look at some of the metrics here. So first, for explaining everything, you can use a classification report. So for classification report, the input should be the target column of the test set and the prediction done by the model, which is stored in prediction_log. And if you print that, you will get the classification report. Okay, so I hope you have seen all these things, what it is. Okay, if you haven't, I'll just mention this particular link. Okay, so here so this is how it looks like, confusion matrix. This is where we can clearly see how our predictions have come. Okay, so what I can do is like, so this is like actual values. Okay, so actual values, positive will mean like 1, it might be good credit score, and negative will mean bad credit score. Okay, so this is like, just wait a moment. So this is like good or bad, and the next one, predicted values, this is our, so this particular thing, these two represents our test y, test_y. Okay, and this represents our logis model, prediction_log. Okay, so prediction_log is represented by the predicted value. Okay, this is prediction_log. Okay, that is what we have named. So here, when the prediction is positive, that means that they are giving it like good. So there also it is like good or bad will be there. Okay, in the form of, right? So whenever the prediction is positive and the actual values are also positive, it is known as true positive. And whenever the prediction value is negative and the prediction values, actual values are negative and prediction is also negative, it is known as true negative. Okay, so accuracy is the first metrics usually you will check. Okay, so accuracy is meaning like the total number of values. So I haven't mentioned this also. So whenever your prediction is negative and actual value is positive, okay, so meaning like it is actually labeled as good, but our prediction came as bad. That means that it has falsely predicted as negative. Confusion matrix should not be trained by versus predicted trained by, which is in sample accuracy. I didn't get that. Confusion matrix means this whole thing. Okay, this is meant by confusion matrix. Accuracy is taken from confusion matrix. I'll show you anyway. I'll finish with this one and we'll see whether you're still confused with that. So false negative means it is falsely predicted as negative when it was actually positive. Then false positive is like falsely predicted as positive when it was actually negative. Okay, just go with the true positive is like truly predicted as positive, and truly predicted as negative you can say like true negative. These, I mean, sometimes you will go into different confusions regarding all these things, but positive is coming, it's true positive. Negative is coming in the matrix, it is true negative. Then from that you can fill the other one. Okay, so accuracy is like, so accuracy, the denominator will come like TP, true positive, plus false positive plus false negative plus true negative, which is like the total number of entries in that particular data set, by which all were truly predicted. True positive was truly predicted and true negative also was truly predicted. So TP plus TN by TP plus FP plus FN plus TN is accuracy. Okay, so it's taken from, you can take it from confusion matrix, or you can just give like, directly there is a function accuracy of ypred and predicted and the true value that is there. So target variable, so this, you can read through this to find out more. Then there are other things also, so everything description is given. Okay, you can go through that. And now I'll go on to the precision and recall. Okay, so just I will show you that yeah, so I'll draw this one once again. So our matrix look like in this way. Okay, this is like so if it like positive negative, I'll give here, positive negative I'll give there, and this was true positive and this was true negative. This was falsely predicted as positive, it was already positive. Okay, so this will become, this is predicted positive and truly negative, so this will become falsely predicted as positive and this will become falsely predicted as negative. Okay, so, this is predicted negative but it's actually positive. Okay, so in this way, if you see which are your positive predictions, if you see, positive predictions are denoted by P. Okay, so these denotes positive predictions, positive pred I'll write, prediction, predicted positive, and these are your negative predictions. Okay, so precision is like how many of the correctly predicted cases actually turn out to be positive. So correctly predicted means predicted positive only we are meaning, that's why I am putting correctly positive. Predicted means TP plus FP, both are predicted positive only. True prediction is also there, false prediction is also there, both are predicted positive only. So total number of positive predictions, and in that total number of positive predictions, how many are actually positive? So how many are actually positive in that? True positive will give you how many are actually positive in the number of total number of positive prediction, that is precision. Okay, that is precision. I'll just denote. Okay, that is precision. And recall is like we have the total true cases or positive cases. So total positive cases are denoted by, so I will just give you, this is like total true cases, true positive, and this is like totally negative, truly negative. Okay, so totally true predictions are like, it's like TP plus FN, those are both positive truly. Okay, so TP plus FN are the cases where it is actually positive or good credit score, and in that how many were like predicted good. Okay, so how many of actual positive cases we were able to predict correctly. So actual positive cases are given by TP plus FN, and how many we are able to predict correctly given by TP. So this is the difference. TP by TP plus FP is precision, and TP by TP plus FN is recall. So both these things we will be using, both these metrics we will be using to find out your model, how good your model is, that you will use along with accuracy and many other metrics. So usually when we will consider recall more when we are dealing with some cases related to biomedical. Okay, that is why it is just given in this way, like sick people correctly predicted as sick, like that it's given. So why we are using, it means for precision we focus on false positive, we can't say like that. Okay, I mean we are taking that particular parameter here, but in precision it is like how many predictions were coming like positive. We are concentrating on predictions there. Okay, from the predictions we are checking how many were true, and in the case of recall we are looking at the true cases, like true cases means this particular column we are using. Okay, so recall is more important in health care data because, like for example, actually positive is this column, right? TP, FN, like that. Okay, so this is like false negative is like sick people incorrectly predicted as sick, as not sick by the model. Okay, sick people are incorrectly predicted as not sick, and false positive is like healthy people incorrectly predicted as sick by the model. So which one is dangerous from these two red like blocks, like cell? Anyway, true positive and true negative are fine because it the person is sick and predicted as sick, and true negative is like person is healthy and predicted as healthy. But from the FN and FP, which is dangerous? You can just put in the chat window. Okay, one has put FP. Any other answers? So in a healthcare case, I mean this varies for different cases. Okay, just I am telling about healthcare. So in healthcare case, if you are already sick but you are predicted as not sick, is that the dangerous one? Or you are not having any sickness but you are predicted as sick, you are healthy but predicted as sick? Which one will be dangerous? Example for it, just think about cancer classification. Okay, tumor classification. So just if you have like this one will be like you have cancer and it's predicted like you don't have, and this one will be like you don't have but predicted as, yeah. So the dangerous one is like incorrectly predicted as not sick. So in this case, which one will be an important, which one will be an important parameter, precision or recall? I mean which one will point more nicely? Because sometimes both precision and recall will come like, if your total accuracy is 99%, your precision might come like 0.97 and recall might come like 0.95. In some other cases your precision will come like 0.95 and recall like 0.97. Maybe some 0.02 difference only will be there between precision and recall, but that time then you have to make sure which model will be good. Okay, in those cases you might have to concentrate more on recall, because why? Recall includes TP plus FN and precision includes TP plus FP. So in those cases it's like that. In other cases where it is like there might be cases where incorrectly predicting is bad. Okay, so very, very rarely, so depending on the problem you have to decide. So then there are many other things also to find how many degree is it like that. So you can just go through this one. Just I'll clear this one. Yeah, then another thing is F1 score. F1 score uses this formula 2 by 1 plus 1 by recall plus 1 by precision. Okay, or it will be like 2 into precision plus recall by precision into recall, like that it will come. Okay, anyway, I mean it's, you don't have to calculate all these things. If you just give that classification report, you can see. So now this is written as precision. For the zeroth class, separately for the classes also you will give. Okay, it will give. So for the first class it is, I mean looking at class 1, which is good, it is actually having better scores, and zeroth class or zeroth target class is predicted actually wrongly. All right, so and macro average is like average of these two, and weighted average is like taking into account the number of entries in 0 and 1. So macro average will simply be taking the average of these two precision of two classes, and weighted average is like seeing how many number of entries are there for 0 target class and first target class. Now just seeing the confusion matrix also, you can use confusion matrix of test y and prediction log. It should be your test data first, and then it should be your prediction data. Then separately, if you want to see what are the true negative, false positive, false negative and true positive values, you can give confusion matrix. It's already stored in this particular name, log_r dot ravel, which will give you the different values in the confusion matrix. Then I'm printing that separately like this. So first I'll print the matrix. So this is how the matrix looks like, and these are the true positive values. Everything is there. So you can see true positive is 159, true negative is 28. Okay, because negative values are less actually. Okay, 0 values in x less, and false positive and false negative, these many are there. So accuracy score, if you calculate, it will be like 159 plus 28 by the total number of things. So calculation is done by using this function accuracy underscore score and test y, which is your test data, and pred underscore log, which is the prediction done by the model logistic regression. Okay, predict is given in this prediction underscore log. So if you do this one, you will get the accuracy. And now, like earlier, I am rounding the score to 2 decimal points, and I am just multiplying it by 100 to get a percentage. Okay, so this is the accuracy. Okay, so this is the same value if you do 159 plus 28 by 159 plus 28 plus 34 plus 29. So 74.8 is your accuracy for this particular model. Now if separately you want to find, you have to calculate and see what is precision, recall and F1 score. You can use this particular thing. I think I have already explained this one. This formulas already I have explained. So just I am giving it. You don't have to use it also directly. You can calculate, but I am giving how to do this one. So precision is this one, recall is this much, and F1 score. So this is for a particular class. Python code confusion matrix is in sample or okay. What do you mean by that? You can unmute and ask.
Yeah, hi. Hi,
Yes.
ma'am. So, I essentially want to know that we are splitting the data into test and training, right? Uh,
Yes.
so, so when we are calculating the confusion matrix, so is it calculating based on the test or based on the training? Uh,
You see it here. Like so, here you can see, no, we have trained our model using our training data, and then we have formed test x. We have used to predict the model, predict the value. Okay, so logis mode is trained on train x and train y. Then we are using the dot predict function to predict what will be the prediction. So this is predicted on the test data. That's why we are comparing. So for example, confusion matrix we are comparing with test target column and the prediction done on the test x column. Is that clear?
yeah, but if we use the training y in place of test y, uh, then what will happen is
Okay,
in
it will actually show more accuracy usually if it's learned nicely. Okay, so in that case, like you can't use prediction is just for a moment. So if you see here, prediction log I have given for test x. Okay, So if you, I mean, doesn't have any meaning there actually, because already it is trained on the train data, right? So if I use it like pred, I'll just use it for training data. Okay, pred train log I'll give, and test, and I'll not give that one. Training data I'll give train x. Okay, so here you see training, that learning is already done on train x, and I'm using the same model predict function on the train x. I'm storing to pred train log. Okay, now so let me copy this, and yeah, I will put it here, and here I will use train y. Okay, then let it be same for everything else. Yeah, so if I do that, now it's coming here in this way, because the number of training set values are more, right? Sustain y, yeah. First I'll run this one. So this is for your test set. Number of test sets are less because only 25% were taken as the test set, and this is like for the training set. So this is for the training set. Now the same thing if I do for accuracy, we have got accuracy as 74.8 on the test set, and for the train set what I'll do is like train y. So if I do that, it's giving like a 1% increase. Okay, so this is what is the train set accuracy. Okay, if you want to find the test set accuracy, I think I didn't copy it, or yeah, sorry, I changed it here. So this is like test set, and this is train set. Sorry, this is train set and this is test set. So just this much difference only is there. So your model has not learned well, that is the meaning.
Exactly, got it.
Yeah.
Thank you.
Now, yeah. So I mean, you can try the same thing with a random forest decision tree. You can use all the models in this one and see how it differs. Okay, now the next one. So import standard scalar from scikit-learn. So the answer for this one, sorry, so the misclassified samples were asked, so meaning like test y not equal to prediction log. Okay, wherever the test set was not equal to the prediction done, I've just taken a sum of it and it gives the misclassification. So the question here was like, so we have gone so much in detail, but the question was the accuracy of the model. So accuracy of the model is greater than 70. Okay, that is the answer. Just I've shown you the number of misclassified samples also. So the answer for this question is C. Now import standard scalar. So one thing you can observe is like we haven't standardized the features. So it's like some of the features are having very high values, some of the features are having lesser values. So we'll see the difference. So they are asking us to import standard scalar from scikit-learn.processing package to standardize the features, then use the same train test proportion, that is 75 and 25%, and the random state should be set to 1. After standardizing the logistic regression model, by what percentage has the misclassified samples changed? So just I've given the scikit-learn link for standard scalar and another example. You can go through that later. So just I've given the column names which needs to be standardized. So why I've taken in this way is like we need to specify which are the numerical columns, because standard scalar is usually done for numerical columns, right? So just mentioning that, taking that call numerical columns and just naming it like features. So train x of that column names I'm taking. Then I'm calling the standard scalar. So standard scalar I have already imported, okay? If you remember, I've already imported it here, okay? scikit-learn dot preprocessing import standard scalar. That is why I'm not importing it again. Now what I'll do is like standard scalar dot fit features dot values. So features contain all these columns, all right, and then I'm using a dot fit function to train the standard scalar on those values. Now I'm doing scalar dot transform features dot values, okay. Then I am storing it in the different, so I've taken it outside for a different data frame. Now I'm storing it again in the same location in the trainx data frame, okay. So this is what is operation is, this much the operation is done there. Now for the test set also we have to do the same standard scalar operation, okay. So that's why we have test set of column names, and we have scalar dot transform feature dot values, and then we will be doing the same operation here. So one thing, have you noticed any difference here? Like for example, we have used standard scalar dot fit here, and we haven't used the standard scalar dot fit in the test set. Can you put the reason there in the chat window? So just yeah, the thing is standard scalar is kind of a function where we'll be standardizing the things, okay. So this is standard scalar, and if you go to this particular site, so what is done, so you know what is standard scaling, right? Either it is standardized to a particular value or it is normalized. So these are the equations that you are usually using, y equal to x minus minimum by min minus maximum, like that, okay. So that is the standardization operation. But what I asked here is like, we have done the standard scalar dot fit on the features dot values. So this is like features are taken from the train set of column names. That means all the numerical columns in train set are stored as features, okay. And we are fitting the standard scalar on the features dot values, means just the values of that particular columns we are taking. So we are using the fit function on the train set, and then after doing the fitting means that making your function or learning. So everywhere the fit, so for a logistic regression, dot fit means that you are making a model learn or fitting according to that particular data. In standard scalar, fit option means you are taking your data and fitting your standard scalar model according to that data. So here what it is doing is like standard scalar is fitted on the training set data, okay. And after fitting that, okay, it is using the transform function to transform the columns based on the standard scaling done. All right, now what I asked is like, I have the test set, and in the test set I haven't used the fitting function. So why is that? You can see the same statements there, only this one particular function is missing. I mean, this particular line is missing, all the rest are coming. So yeah, I already fitted there, but don't I have to fit there with the test set?
No, madam.
Yeah, Why shouldn't you fit it with the test set? Any reason?
Yeah, we are testing what is fitted right now, whether it is
Yeah,
good.
but okay. Um, how can I ask that? Like for example, so usually if you have a set of functions here, like what are the things? Yeah, age, c amount. So what is it doing is like it will be taking the min and max of this particular thing. If you're doing a normalization, that will be like x age, I'll put, okay, x age minus min age by max age minus min age. Okay, so this maximum age and min age will be taken from the train set. Okay, so usually this is something which had some kind of contention earlier. So the contention earlier is like, in this particular problem we didn't look at that earlier, because in this particular problem we have already splitted the whole data set as train and test. Okay, first we have splitted that, then we did the train and set, and then we did the scaling. Okay, so scaling we did on the train set, and we are right now using the same scaling to the test set. Same scaling we are using on the test set. So this is how we are doing. In some cases you might see like data set is there, and first of all you will be doing a scaling operation. What I'm asking is this one actually. You will be using a scaling operation, and then you will be splitting as train and test. Okay, so which one of this is good to use or acceptable to use? Is this one fine or this one? Which one is good? So right now in this particular thing, it is like train is having the standard scale fitted with the train set and using the same standard scalar function for the test set also. In this case it will be like data set is there, we will be using the standard scalar, so it will be like only one set of instructions will be there or lines will be there. It will be directly like standard scalar dot fit the total x set and total y set. Okay, and then you will be doing the splitting. So which one is better? Is this one better or this one? So this is like one kind of doubt that everyone will have usually, and maybe sometimes you do this ML problems also, you might end up doing one of these ways. Okay, so you have to, every time you have to be careful that you are doing every set of operations. Yeah, I will tell you. So mainly many set of operations that you will be doing in a data set when you get one are like, you will be doing some different data pre-processing things, then you will be doing the standardization. Okay, and then you will be fitting like many different transforms you will be doing sometimes. Okay, so one thing you have to make sure is that your test set is something which should be very pure. Okay, what it means is like whatever operations that you are trying to do, it shouldn't be based on the test set, because test set is something like, so right now we have the data, we are splitting the data as train and set, that's why we are doing both these operations together on the training and testing set. That is the usual case, but actually we are, why we are using the test set? We are using the test set so that it mimics like some new data which is coming to your model. Okay, so right now if I do it like, if I do this particular standard scalar operation on the whole data set, for example our whole age, just you see. Okay, so age goes like 30, 32, 35, 37, 50, like that it went. Okay, and when you splitted the train and test set, some data went like this: 30, 37, 32, like that, and your test set went like 35 and 50. Okay, so this is your train and this is your test. Okay, so now if you take a standard scalar here, which is your x min here, x min will be 30 and x max will be, that age max will be 37. So you will be doing your scaling operations in these values, and test set contains 35 and 50. So you will be applying the same operations there in the test set. Okay. But when you are using the whole data set, the test set also is used for calculating your scaling. So you might see that there is some error here because 35 and 50 came in the test set, so your model might not work correctly. You might think like that. But our intention is like test set should be something which is not seen by any of the operations which are done before the learning process. So this is actually not the learning process. We are just doing some transformations here. Okay. So in the transformations, it shouldn't view the test set. It shouldn't take any values from the test set. So that means that first we have to do the testing operations, splitting operations first. Then only you should do the other operations. So that means that first you will be splitting the age like 30, 37, 32 and 35, 30, and then you will be applying this scaling on train set first and using the same thing. Using the same thing means some data might have been learned here. With that you'll be applying to the test set also. Might seem like it's not good, but this is the case where your test set is like a new data coming to the model. So you have to make it like that. So why someone has raised the hand? So I hope this is clear now. Is it clear? So the right one is like this one. Okay, this is the right one. Right model is this one. So you always have to do the splitting first and then do other operations. But when you do the splitting first, the same operations that you have done for the training set has to be applied to this test set. Just the thing is that all the operations would not be depending on the test set. The data won't be taken from the test set. You have raised a hand. You can unmute and speak.
Madam, in our assignment in fourth week, we got two different sets on training and test sets, different.
Yeah.
So how do we call them, ma'am?
Yeah. We'll come to that. What is the time? Yeah. Okay. If you do that, just you can directly call here. I mean, I'll be sharing this one. I've put this one like train service data frame, like this pd.d csv, and test service data frame in this way. Separately you have to call. Now the same things will continue. So here you don't have to split it, right? Because it's already splitted as train and set.
Okay.
Yeah, that's train test split function need not be used here. Okay.
Okay.
Yeah. So what we were doing here. So actually so we have looked at logistic regression and standard scalar also. So standard scalar we haven't looked at. Yeah. So standard scalar is that one. So if we run that, and then we do the same operations in the logistic regression, because rest are all same. Okay, just we have given it to train and test set differently after the scaling operation, and then if we did that, there is like a one more increase. Earlier it was 74.8 something, now it has become 77.6, and the misclassified samples in this case is 56. So the question was like, if we do a standardization, how much percentage change is there in the accuracy? So I've just given like first is like test 5 prediction, this one dot sum minus earlier test y. So all in both cases the test will remain same. With standard scalar I have named like prediction underscore log dot stn, and for the other one I have given prediction dot underscore log. So if you do that, percentage change in samples will be this one. Okay, now then if KNN classification is applied, so if you want to apply KNN, the API as well as example I have given here since the time is less, so you can go through this one. What I've given here is like, so this is the API to call, okay, K neighbors classifier. I think you have this question in your practice question. I think you have to mention how many neighbors are there. So it is like you will be calculating or splitting the data, and you'll be finding a data point, and you will be finding which all are the neighbors, which all closer neighbors are there to that specific point, and that's how you will be finding. That is a basic thing behind that. So if you specify that this many numbers are there behind a particular point, so I will just see whether I have it. So if you have something like that, so this might be your data. This is a fraud data set, okay, so 0, no, and yes, okay. So if you are like looking, so that one, so if you first is like, it will be one point will be taken in between, okay, one point will be taken in between, and we will find this point, okay. Based on this point, we'll find the number of neighbors nearby, and based on the number of neighbors, we'll be checking whether it will fall into which category, okay. So specifying the number of neighbors will influence your result in the K neighbors classifier, okay. So that's why I've just automated this operation. So K neighbors I've given as I, so that I've given a for loop to change its values from 1 to 25, and then I'm calling it and using the same other functions. I'm using a fit function for the train set, and then using a dot predict function for the test set, and storing here misclassified samples. I'm appending it one by one, okay. And if I run this one, all the rest are similar, okay. You have already seen accuracy score, right? So if I'm doing that for K neighbors as equal to 1, this is the accuracy score. When it is 5, this is accuracy score. So for till 25, I have seen the accuracy score, okay. So this is how you can do a K nearest neighbors. Now, multiple linear regression model is built on the global happiness index given by GI report. So I have loaded that GI report also. Then we will load that data. So what is the question? What is the RMSE of the baseline model? So baseline model is like a model which is the most which has the most like you can say it is the model which is having the better accuracy, okay. It is like a fundamental model or a reference model. Which application is best for Python? Depends on which system you are using and what is the complexity of your program. If it's a very complex program and your system requirement is less, you can use the Colab notebooks. And if your net connection in your area is less, then you have to go for a system based, IDE based or something. Then you can have Jupyter Notebook or Spider IDE or even Visual Studio Code, okay. If you are someone who are very proficient in using GitHub and GitHub Copilot or something, then you can use Visual Studio Code. Spider, yes, I mean you can learn different IDEs, okay. Spider is good. Some people are very find it easier to do in that, but I usually now do it with Visual Studio Code and as well as Jupyter. So depends on your preference and how your data looks like. If you want to have a very a notebook kind of environment where you can place your data as well as your text data along with that, it's better to have a notebook environment where so you can use a Jupyter notebook. But coding something and putting a function and all, the VS Studio Code is fine. So if you go to Visual Studio Code, this like, okay, for example, they already have this kind of an interface. Maybe you can find it better for like your GitHub, and you can directly take and give to your GitHub account. You can do, and just you have to like manage it. I mean, you have to sign into that, and if you type something, you can have the Copilot also if you are doing that. Okay, so depends. So
Okay, ma'am.
yeah, so data GHI, so like pd.read csv ghi report I've already loaded. Now here the question is like RMSE. So RMSE is for a regression problem, right? So regression, your categorical data is like continuous. Okay, so setting the features and target in this is given like in a different way. You can use the other way also for giving your features and target function, but here it is like I'm converting it to a list and doing it in this way, different ways. Okay, so if I'm just printing that, this is how it looks like. And if I give like data.ghi.loc, I'm using all rows and features, which is these particular columns, which are the rest of the columns, and the target column is h score. So I am just giving like target I've already placed in like h score. So if I run this one, it will store as x and y. Then I have train x, train y, test x and test y given in this way with 75-25 splitting ratio and random state as 1. Then since it's a regression problem, you don't have your normal classification metrics. You don't have accuracy here also you can do, but it's a different way. Accuracy, precision, recall, all those metrics are usually for classification problems. And for regression problems, you have mean squared, root mean squared, mean absolute error, all those different things. So right now they have asked for the RMSE of the baseline model, which is root mean square error. So you'll have the error first, you'll square the error, find the mean of the squared errors, and then find the root. That is the meaning. So for that, I have to call the mean squared error from scikit-learn.metrics, and then I can use the value. So base spread, I am giving np.mean test5 just to find the test data mean. Okay, then the same thing for all the samples I am using, and print base spread. So this is what is the mean value. Okay, now if I am taking that, so base spread I am taking and test y I am taking, and I am using the mean squared error function, so it will give you the mean squared error value. Then I am using a square root function to get the square root of that mean squared error. So that is why how you will get the RMSE value comes like 1.06. Okay, so the answer would come like B. Okay, then next they are asking you for an R squared value on the test set subset. So here to calculate that, you need to import this one, linear regression. All the details are given. You can go to each of these sites to learn what is meant by linear regression. Okay, okay, and I've given a link for coefficient of determination, which is the R squared, R2 square. So how you will do that? This is like linear regression I will be calling for a model, and like the same kind of steps we'll be doing here. We'll be doing a fit function on the train x and train y. Okay, and after forming the model, so it's coming like this linear regression, we are using all default values here. Then we will be using the score function. Okay, so linear regression model, that like that I have named it dot score. This is the train test score and test set score. Okay, differently I've calculated this time, like we have seen earlier also for train and test set accuracy. So here is like dot score means the R2 score. So R2 score of the train test we'll get from here, and R2 score of linear regression of test we'll get from this test set values. So if I run this particular thing, the R square score, just I have given it into 100, okay, that's not required also, but if you want to see it as like a percentage, you can do that. So this is the score 0.76 and 0.81. Okay, now so they have asked you for the R square on the test set. Here they have given us in the form of a percentage, that's why I have given the into 100. Usually we don't use that. Since they have given the answers in those ways, we are giving like a percentage. Okay, now so the answer here for the 7th question is D. So till now I think the answer, I mean, are you clear with that? So because the rest of the things are just like different theoretical questions only. So this one you can answer. Which of the following statements are true about linear regression? You can just put in the chat window. Okay, so the true statements are linear. Are you telling? So the truth statements are linear regression assumes that there exists a linear relationship between the independent variable and dependent variable. That is true. The next statement, errors are assumed to be independent and normally distributed. That is also true. Okay. The third option, the percentage of variation in dependent variable as explained by independent variable or variables is expressed by R squared value. That is also true. Residuals are product of the predicted value and actual observed value. Is that true? Is that true or false?
False.
Okay. So your answer right now will be A, B and C. A comma B comma C. Then residuals, they are the difference between predicted value and actual observed value. It's a difference. Now which of the following statement is inaccurate about logistic regression? Can anyone say or put in the chat window? So is this correct? Doesn't require a linear relationship between dependent and independent variables. First
Yes.
one doesn't. Actually, you require a linear relationship. Okay, I mean, linear relationship means like when these much values are high, then your model is yes, then the other one is not, like that. So it's like a linear relationship is there, and then you are doing the logistic operation. Okay, so that's also a linear model only. Okay, if the model is kind of, there are different models which are used for non-linear data set of non-linear type problems. Usually it's like SVM or something. You can learn it later. So right now logistic requires kind of. Now so which of the thing, I mean, which is inaccurate, it is asked. No, so like, I mean, it's like logistic regression requires a linear, okay, but at the end it is seeing the probability between that. Then value of logistic function being a probability will range between 0 and 1. Is it true? So how is the variation coming for logistic function? It's between 0 and 1. Okay, so first one is kind of right. Doesn't require, if it's a linear relationship or doesn't, it's not a linear relationship also, it will work, but it will work more for a linear relationship. The accuracy will be more. If it's non-linear, also it will work, but there are other models which will work. But anyway, for this question it will be kind of accurate. Okay, the cost function of logistic regression is called log loss function. That's also true. The fourth option, dependent variable can be both numerical and categorical type. This is wrong. So the answer will be only categorical values are possible. So answer is D. Now in a KNN model, by which means do we handle categorical variables? So from these, which are the ways by which you can handle categorical variables? The answer is dummy variables can be used to encode different values contained in a particular categorical independent feature. So answer is B. Okay, so this is the previous assignment. The present assignment I've just mentioned, you can do many other operations. So I'll be sharing this notebook, and in there I've shown different ways to form the label encoder. Okay, so one method of this one, another method of forming like encoding. So this we have seen mapping earlier. Okay, so I'll be sharing this one. Okay, sharing this notebook as well as maybe an extra notebook. If you have an extra class in the last week, I'll be sharing other models. Okay, so I'm not sure, they haven't still asked for the extra class, but if it's there, I'll share the other models. Okay, so everyone is fine with the present assignments?
Yes, ma'am.
Okay, okay then, thank you everyone.
Thank you, ma'am.
Thank you, ma'am.
Have a nice rest of the day.